Yuli Chetapalli is a physician, an author, a speaker, and an innovator. And on this episode of IT Visionaries, he joins Ian to discuss the role of AI and technology in the world of healthcare. Yuli has worked in a number of high-level roles, both as a medical doctor and a chief innovator at hospitals, as well as in medical centers and institutions such as Kaiser Permanente and the University of California, San Francisco. He has led a number of initiatives to bring technology into the medical field, and he is on a mission now to inform and empower people with artificial intelligence. He and Ian discuss all of that and more on this episode. This podcast is sponsored by the Lightning Platform by Salesforce. Salesforce just introduced the Lightning Platform Mobile, the low-code mobile app development platform that empowers anyone to easily build, publish, and manage AI-powered mobile apps for employees and for customers. Find out more at salesforce.com/buildmobileapps.
Welcome to another episode of IT Visionaries. I'm Ian Faison, Chief Content Officer here at Mission.org. And special guest in studio, Uli, how's it going?
Hi, thank you for having me.
So today we are going to talk about Uli's book, Punish the Machine, The Promise of Artificial Intelligence in Healthcare, and a bunch of stuff AI that is really interesting and at the cutting edge. You have had some stints at some really important companies doing research, writing about that research. You recently wrote an article detailing 99 changes that you'll see in future hospitals, and it's all stuff that, like I said, is at the cutting edge. But first, how did you get into all this stuff in the first place?
Well, let's see. I've been an emergency physician, started, trained in LA, and did a master's in public health. When I first came to the Bay Area, I got this job at Kaiser Permanente as an emergency physician. And I went on the administration track, which became the assistant chairman of the department and then the chairman of the emergency department here in South San Francisco. But administration was a little boring for me. So I started doing other projects. One of the projects I did was help start a call center in Pasadena. And then the other project, which is my most recent one for the last 10 years, I would say, was start a research group called CREST Network. So myself and another physician, we banded together, and he did the grant writing and I did the technology for the group.
When did you get the idea to write the book, Punish the Machine?
So my work with the CREST Network has been very interesting. So this is the first time we had the technology to be able to take patient data and analyze it and give feedback to the physician while they're seeing the patient in real time and at the point of care. So in other words, if a physician is seeing a patient, let's say a patient comes in with chest pain to the emergency. So the physician talks with the patient and examines the patient and runs some tests. While doing that, what happens is when they are in the patient's record, they click a button that takes them to our platform, which actually pulls all the data from the electronic health record and walks them through a couple of screens and gives the physician a risk score on that particular patient. So this is very patient-specific and condition-specific. It tells the physician what are the chances of this patient having a heart attack in the next 7 days.
Wow.
So it predicts. And it's very accurate.
Wow.
Very, very, very well received by the physicians. And we have, 21 hospitals in Northern California. And so it was implemented in half of the hospitals, and the other half remained as controls. And we did a clinical trial to study the effects of the application. And we had some very, very, very good results where the length of stay decreased, the amount of testing decreased, the number of hospitalizations decreased. And so we are very happy with what we are seeing. Although the final results haven't been published yet, as the study is still going on, but we are seeing some very encouraging results. And that led me to thinking about machine learning as a more of a tool that can assist physicians in all kinds of instances. And that's what led to the writing of the book.
So the subtitle of Punish the Machine is The Promise of Artificial Intelligence in Healthcare. Do you feel like there has been a promise that has been made for AI in healthcare, or that it hasn't been made yet?
Well, technology in general, there have been a lot of promises that were made that did not come true, especially with electronic health records, where the technology is very clunky and cumbersome, and it's very hard for physicians to work with it. And it's kind of old technology.
Yeah.
And so what happens is, they spend a lot of time, entering data, mainly as data entry. And the main
actual physicians.
The actual physicians. So when you go see the doctor is, facing towards the computer and entering data while he's talking with you. And so what it does is, in a way, we are punishing the doctors to do this stuff. And if you don't do that, obviously, it is connected to billing. So indirectly, it's connected to the income of the physician. It is connected to medical legal aspects, where they have to document a lot. And it's also connected to regulatory agencies which are watching the practice. But the main purpose, which is, how do you improve the quality of care for the patient, that is lost in the current system, where electronic health records are taking a lot of time and punishing the doctors, but it's not giving back the return on that investment. And so the book is titled Punish the Machine because I want people to stop punishing the doctors and punish the machine instead. We should expect more from the machines. We should expect more intelligence, much smarter machines, which will help the doctors practice better medicine, take the burden of work away from the doctors, and provide good quality care for the patients.
Well, it felt like every joke in the 90s was about how bad doctors' handwriting was, right? So I think we got to this point where we were all so happy that we no longer had to see illegible handwriting. It's like, wow, they can type it. This is great. And I think that, the next level of that is like, you just type it, and then it's very non-predictive.
Yes.
What's so exciting about AI is the predictability, is leveraging data and trends and things to be predictive, like you're talking about with predicting heart attacks. Like, what does this predictive analysis look like from what you're seeing from both your studies and then outside of your study?
Sure. We've done several studies both within Kaiser and Permanente, and also outside. What we have seen is that if you can predict a bad outcome, you can also potentially prevent that bad outcome. So for example, if you can predict what are the factors that contribute to someone having a stroke, which means that if you change those risk factors, you could actually decrease the chances of having the stroke. And so that is very powerful, and which we know to a certain extent, but not in such great detail and not personalized to each individual patient, because each individual patient's risk factors are different.
Yeah.
And sometimes we are seeing risk factors that we never thought were risk factors. So there is some new knowledge that is coming out just because we have this technology that can scan large amounts of data and predict bad outcomes. So it's unprecedented where this much knowledge is coming to the physicians, and that can be very helpful in their practice.
Obviously with the title of the book being Punish the Machine, and you being firmly on the side of the physician, the operator on the ground who's doing the work, do you find that, over the course of your career, you've seen physicians that were kind of always looking for this level of analysis, but didn't know how to do it? Or was this something that they wish they had technology that could see these things and it just never materialized?
So one of the problems in healthcare is the business model.
Yeah.
And the business model has always been, when the patient gets sick, you take care of the patient. And so that's how you get paid. So physicians have got accustomed to that way of practice, which is, we wait for the patients to get sick. And when they get sick, we intervene, whether it is medicines, prescriptions, surgeries, or whatever procedures that they can do to make the patient better. But if that's how they're going to get paid, and that's what they know how to do, and that's what they do more and more of, and that's called fee-for-service business model of healthcare. So there needs to be a change in the business model of health, which is value-based care.
Absolutely.
Exactly. Value-based care is where the idea is to keep the patient healthy and not allow them to get to a stage where it becomes very serious, right? So how do we prevent? How do we do the things to prevent bad outcomes in these patients? So it's the flip side of that business model. I think that's where the industry is going, and that's what needs to happen.
Well, and I think that ultimately a lot of people in healthcare are just stuck because they want to do that for their patients. Like they want this, but the business model is such that they couldn't escape it if they tried. My brother works in physical therapy, and at some of the private clinics that he's worked at in the past, it was like, somebody comes in, their insurance allows 40 sessions. Those people are going to bill 40 sessions. They're not going to bill, hey, no knee pain. Knee pain's gone at 15. We're billing 40, and he left those places. But there's a lot of folks that the income of keeping their clinic alive depends on that type of revenue. Back to the predictability piece of this, same thing in physical therapy is like this idea of prehab. What are the steps that we need to do now that can get out in front of injury? I mean, I think so much of the consumer side of this is from the patient side is you just don't really know what you can do to like better increase your health. Do I take multivitamin every day? Do I do whatever? And I think that that's exciting and empowering now that you have, physicians and people in healthcare that are going to say, hey, backed by data, here's what you should be doing to limit risk factors.
Exactly. And then physicians have some of that knowledge, but it's not, number one, it's not very personalized. And once we personalize it, then I think the patient, will play a much bigger role in taking care of their own health, right? Hopefully the physician and the staff can support that patient with information and stuff. But that was not available to us other than the simple things, don't smoke, diabetes, control your sugar, control your weight, exercise, eat, plant-based diets. So those are some of the simple things. But as we get more data on various other diseases that we didn't even know that there are risk factors that hopefully could be controlled.
Yeah, my girlfriend, shouts to Becky, was part of the ACSM at Cal State East Bay, and one of the studies that they did was about basically trying to test like bone density and like what allows your bones to be healthier later on in life. And one of the things that they were testing all these different things, was about vertical jump. And so like one of the things they found is that there is a good correlation between people who had vertical jump, like a strong vertical jump with their bone density. And it's one of those things where it was so eye-opening to me as someone who like played sports all growing up and all of that you could look at factors. But, and the problem is that the technology is not democratized. You can't get, I forget what it's called, but the machine that measures your bone densitometry, like 99.99% of the world can't just like roll in and check their bone density. But if you could generally correlate that if you have a good vertical jump, that your bone density is probably good. And, that's not like published or anything like that. But it's this idea that with the right amount of data, with the right amount of analysis, that you can start to be more predictive looking and come up with like surrogate measures to test these things. And again, I didn't know anything about this. So it's pretty mind blowing to me. In your work, is there a level of data or like an amount of data for these like machine learning algorithms or for AI or for the things that you're looking at, like a minimum viable data set that you're working with? And then like additionally, how do you increase that amount of information?
So the exciting thing about consumer based applications is that there are a lot of new technologies that are coming into the market. And it's early, some of them may or may not survive, may or may not work, but it's good to see that there are so many wearables, so many new pieces that are coming into the market. So what needs to happen is that, like your girlfriend did, somebody needs to study.
Yeah.
For example, what will predict in that somebody is anxious? Right? Does the heart rate go up? And what happens to the breathing? What happens to the sweating? So there are all these wearables that can measure all those things, right? Yep. So there are some studies where they have looked at, just by checking the moisture on the skin, you can tell how often this person is getting anxious. And, that continuous data that is collected, and then you run machine learning on those, and you compare that with the patient's symptoms that the patient is reporting, and you can actually build a very good system to detect, how often does this person get anxious. Like that, you can build for various risk factors, maladies or diseases. And that's all new science, that has never been done before because we never had access to these variables. We never had access to the technology which can do the machine learning. We never had this continuous data that we are generating. So the next 5 to 10 years is going to be very exciting because there will be a lot of new science that will be built on these.
Yeah, we work with Splunk, and one of the things that, in talking with their team, and we just interviewed Splunk CEO, Doug Merritt on Mission Daily, one of our other podcasts. And what's so interesting about this new age is this approach to take all of this data, these data lakes, and not mess with it, not try to go in with these preconceived notions and assumptions and all this stuff, and then leverage that data to get real kind of business outcomes. And I think it's much the same with healthcare, where we have the pre-technology generation of healthcare that is now has essentially what's going to be limitless amounts of data with sensors and biosensors and all of that sort of stuff that you were talking about. We're going to be able to store it in a more efficient way than we have in the past, and that's been starting to happen. Your mission is to deliver, artificial intelligence enabled solutions to physicians at point of care. Do you feel like is this the very start of this artificial intelligence kind of revolution for healthcare?
Yeah, that's correct. We are in the very, very early stage because right now we're just excited that, wow, we can collect data. Previously, this was not possible. Now, the question is, what do we do with the data?
Yeah.
And is it significant? Can we predict something really significant using that data and algorithms? And if we can predict, can we prevent it? And if we can prevent it, does that make the outcomes better? So there's a lot of other steps that need to happen before these tools can be used by the physicians.
Obviously infinite more about this than me, but from my cursory knowledge of research, you have so much control and you have controlled environments, and you're, stripping away all of the different pieces so you can measure certain variables. As you get these large amounts of consumer data from things like biosensors or whatever it is, in an inherently uncontrolled environment, How does that change how research is done and AI and machine learning is done? Because it seems like there's so many factors at play that could potentially like skew data in one way or another.
That's very true. And so the research methodologies are changing too, because you're right, in the past, all the clinical studies were done in very small groups of people, pre-selected, very clean data, and almost sterile data, right? And then you take that small sample, you come up with the hypothesis, you test that hypothesis, and then you get an answer. And then you see if that answer is statistically significant. And then if it is, that means that it could be generalizable, which means that it can be used, that knowledge can be used for general population. Now what is happening is that instead of picking a sample from a population, you have the data on the whole population. Yeah. And that is what we call real world data. And so you have to figure out, how do you study this real world data that is coming at you, right? And so there are, new techniques and new technologies, actually new algorithms that are helping us to make sense of that real world data. And so the methodologies are going to change, and there's new, methods that will help us understand this real world data much better.
What about collaboration? I think that we talked to one of the first employees at Waze, and she was telling us about Diane Eisner about like Waze has more data about a city and like traffic patterns than that city could ever have about itself, right? Like just inherently, it's like it's one of these paradigm shifts, right? You would think that for years the city knew itself well, and now with technology, a third party can have infinitely more about it. And so one of the things that she was saying, she was like, we work with cities now, or Waze does, to say, hey, this is what your traffic patterns are showing. This is where, there needs to be a stoplight, or this is where different things can happen. This is where, all of that. With the rise of those third-party data and collaboration, what does that look like for healthcare? Obviously, we have huge PII issues and all of that sort of stuff. But at the same time, you have things like the BioFits or the Apple Watch, or, all these different things that are getting massive amounts of data. And then you have research institutions at a lot of different universities or other places or private places that would love to have the access to that data. How does that work?
So the future of research is based on collaboration, as you rightly pointed out. So the collaboration has to be physician scientists and data scientists, and then you have engineers, hardware and software engineers, who have to work collaboratively to come up with solutions. So one of the things that I see is that when a startup wants to do, let's say, a wearable, I feel that they need to have a collaborator, a physician or somebody who understands the clinical knowledge behind it. Because otherwise what happens is, you have all this data and you come up with conclusions, and then finally you realize that, nobody cares about that. So I would rather have that collaboration done early on, where there's a clinical scientist, either a physician, nurse, or a psychologist, who is actually designing these studies so that the outcomes or the results of that study will be useful in practice.
Yeah.
So, definitely there's going to be a lot of collaboration, not only just the engineering and the clinical science, but also on the biotech side, on the medical device side. There's a lot of, infusion of this data science into those modalities.
Did young Uli ever think about, do you think you'd believe that looking forward how much work you'd be doing in data science? It's one of these kind of things where it seems like your career has kind of brought you to this point where you're working with technology so much, but it might not have ever been the case.
No, actually, while growing up, I thought I would become an architect like my dad.
Oh, there you go.
I do like structures and design and stuff, but this is very fascinating stuff. It's not just fascinating, for the sake of curiosity, but this is this is the stuff that'll save lives.
Yeah.
This is the stuff. This is the real stuff which will prevent these bad things from happening. Like the opioid crisis. That is such a disaster that we could have prevented that if we had enough data science understanding the behavior of the patients. How much opioids do you need to prescribe before somebody gets hooked on it?
Yeah. So I was just reading a study last night. Let me just see if I can pull this up really quick. Hold on. We'll cut this part out. I'll sound smarter. By the way, is there any stuff that you wanted to touch on from some of the like theory application background stuff? So
I think where machine learning and artificial intelligence will be used would be in 3 areas. I mean, I'm not talking about the administrative stuff. How do you get appointments, or how do you predict the flow of patients? How do you track the flow of patients through the hospital? I'm talking more about the clinical science. There are 3 areas where I think it'll be most useful. And number 1, as we have discussed, is prevention. Prevention, right now it's very generalized. At age so and so, you need to get these shots. At age so and so, you need to get this test done. But what if we can personalize it? What if we can find the exact predictors in each patient at scale? Mm-hmm. So that is one application. The second application is diagnosis. As you can see, diagnosis is it's not a black and white thing. It's a very gray area where certain conditions slowly creep up on you. So can we catch those conditions early on and be able to treat that so that not too much damage is done to the body? The third area is in the treatment realm, where for certain diseases we have 10, 20 different drugs treating the same condition. And then you go through this trial and error method of finding the right drug for the right patient. And what if we could predict which treatment is going to work best for this specific patient? So a lot of the trouble of doing trial and error and the damage and the side effects, all those things could be decreased, I think.
Do you think that sometimes in healthcare, perfect is the enemy of good, with like a lot of times where you have physicians that are recommending things and they just don't, they don't have enough, background information or anything like that they just don't have that. Ultimately, it comes down to the data where they're recommending a certain amount of things just without enough information to make the most informed decision possible. But there was some apprehension over the years to add those type of things in, because ultimately there are so many options. For example, it's like, well, there's 27 different things. Yeah. Because I feel like, it's happened to me as a patient so many times where it's like, well, we could do this, or we could do this, or we could do this, or we could do this. And like, I'm going to start you on this, and then we'll see how it goes.
Yeah.
And it doesn't feel as a patient like it's like
the doctor knows what he's doing or she is doing.
And that they do, but there's also this sense of like, I feel like we could use something better to predict.
Exactly. So medicine is an art and a science.
Yeah.
Okay. No doubt, there's definitely art to it. Connecting with the patient, showing empathy, building trust with the patient, all those things have been a mainstay for physicians, and they have been shown to have a positive impact once that physician-patient relationship is built. And so that is the art part of medicine. But what I'm talking about the science part of medicine, where I think there's a lot of room for improvement. Mainly because, medicine is such a complex subject, and there's so many things that can go wrong with people. Yeah. And so the clinical science is not able to keep up with all the stuff that happens to people. And so data science and machine learning will be a great addition to the science armamentarium for the physicians.
Yeah, that toolkit, letting
Exactly.
letting that stuff augment what they're already doing. We always talk about AI as augmented intelligence, right? It's this ability
Exactly.
to give your folks on the ground superpowers. Like, ultimately, it doesn't matter if the, CEO of the hospital has AI on a day-to-day basis. It matters that at the ground level, the physicians do.
Exactly. Because those are the ones that will affect the lives of people and make them better.
So, and the study that I found, so there's a press release that Splunk and New York Presbyterian are working on developing an enhanced data analytics tool to expand proactive security measures for both patient records and to prevent like misuse of opioids. Like that's the stuff that's so exciting, right? It's like those are the things where it's just so exciting to think about leveraging massive amounts of data, patient records to solve something like the opioid epidemic, but also to prevent misuse because there's just so many. I mean, I don't know what the recent stats are for preventable death around, opioid use, but it's astronomical and it's preventable. I mean, that's the thing that's so exciting where technology has an opportunity, like you said, to save lives in a major way.
Exactly. And, I'm very optimistic about that because right now we are flying blind as far as, some of these drugs that we prescribe or the procedures that we do, we are not studying the long-term effects of those. What happens, 1 year from now, 2 years, 10 years from now, 20 years from now. And so we don't know that because we are not studying. There's no research project to track all those outcomes. But with the improvement of data science and the machine learning, I think we should be able to get a lot of those automated data collection and data analysis going so that we can actually know what we are doing, where it is a problem, where it is a benefit.
Any other stuff from the book that you wanted to talk through? I mean, there's so much stuff in here, like we could literally go all day.
So a couple of things that I stress, and that is, how research has to change. So far, the research has been, usually funded by some funding agency, whether it is the government through National Institute of Health or through industry, let's say a pharma company or a medical device company. They have been funding the research. Now, if you can imagine, a pharma company, their main purpose is to find a drug that can cure a certain problem, and hopefully it'll be a good business decision for them, right? Mm-hmm. So if they think that it's not a good business decisions, then they may not fund that research. So one of the problems that happens is that a lot of new drugs and new procedures and new devices are introduced into the market, but there's very sparse data on how they perform in the long run. And so one of the call I have for physicians is that, whenever you practice medicine, make sure that you know what happens to those patients and where that data is going. So the healthcare companies, especially the hospitals and the clinics, they need to keep track of their data, and they need to figure out what are the best options for their patients. So I would encourage many physicians, especially the younger ones that are coming in, to learn data science, to understand their data. If you're a healthcare company and you can't just say, oh, we don't do research because that's done somewhere else in the university or somewhere, that should not be the case. I think now there is an opportunity for every institution that is collecting data to be able to do research. And so I would highly encourage physicians getting involved in that and driving that.
What are some places that folks can go to find information like that? Like, for the technology leaders that we have listening to the podcast that might be in healthcare, what resources could they share with their physicians? First off, read Punish the Machine. There's one. But yeah, what are some other places to go? And also you could check out, your website at InnovatorMD.com. But what are some resources that you've used over the years that have been helpful?
So some of the things that I've been doing is where, building that community of these people who are interested in developing these new technologies. I run a group called Society of Physician Entrepreneurs, and there are many chapters, throughout the country. It's a nonprofit. It's a global biomedical innovation network. The website is sopenet.org.
And we'll link it up in the show notes as well.
Sopenet.org. And there are various chapters in most cities. And so getting involved in the communities helps physicians learn, looking at, what are the new technologies, and hopefully helping those entrepreneurs and innovators, helping them with their clinical science knowledge so that they can build the right products and right services. And that would be great. It'll be a good networking and also an educational thing for them.
Yeah, I mean, we sit here, fortunately, in Palo Alto right now, but kind of in Silicon Valley, and we talk a lot about the advantages of being here and just how many technologists and how many people are just working on crazy hard problems. We're a stone's throw from Google and Facebook and Stanford right now. And part of the thing that's so exciting here, and I'm sure that you feel the same way, is especially when it comes to machine learning and AI, so many people here specifically are working on it. Is that something that, you feel like you're kind of, democratizing that, what you learn here at speaking engagements and different events and things like that you can help bring to physicians all over the world?
Yes, we do. In fact, what we do is we have a YouTube channel called InnovatorMD, where we broadcast all the talks of these startups. So you can go to YouTube and search for InnovatorMD, and there are videos of all the talks over the years of these entrepreneurs and innovators when they talk about a subject. That's a good way to learn about what's happening in the industry and what is cutting edge and where there is a lot of traction. That's one way to learn. And also staying active in the community of entrepreneurs is a great idea. We are blessed to be in Silicon Valley.
Yeah.
But we definitely, one of the big things I'm trying to do is, how do we spread this word to the rest of the country and the rest of the world? So please check out that channel.
Cool. That's all we got for today. Any other stuff?
No, I'm hoping to do a conference in January, so stay tuned.
Yeah.
It's going to be a global conference for all the physician innovators. So stay tuned and sign up for our newsletter and our video channel.
Awesome. I love it. Super excited to follow along, and thanks for all the work that you're doing.
Thank you for having me. It's a pleasure.
Thank you again to our friends at Salesforce. IT Visionaries is brought to you by the Lightning Platform by Salesforce. Salesforce just introduced the Lightning Platform Mobile, the low-code mobile app development platform that empowers anyone to easily build, publish, and manage AI-powered mobile apps for employees and for customers. Find out more at salesforce.com/buildmobileapps.